Okay, so now you've been doing the orientation stuff, and I wanted to, first of all, thank you for responding to all that kind of stuff, but also to give you some tips as far as how to succeed in this class. And right off the top, I wanted to show you, this is just a typical Canvas course for astronomy, and wanted to first of all point out the fact that, quite often, and this view may be different than what you see in a student view, but quite often, I know you have a to-do list, quite often you have a calendar. My suggestion is ignore those things for the rest of the semester. Each time you come into the course and you're ready to do your work, don't go through your to-do list, don't go through the calendar, go directly to the module that you're supposed to be working on. So a lot of you have done the orientation, so you're ready to move on to Module 1. So when you click on Module 1, the reason why I encourage you to do it this way is that you see everything that you're expected to do this week. Here's the reading assignment. Now the first two chapters are scanned for you if you haven't gotten your textbook yet. So those are available to you. Notice that there's also a link to the lab activity, to the reading quiz, and to the discussion board. To be counted present this week for Module 1, you need to do the lab activity and the quiz. If you complete those on time, you're considered present for that week. The discussion board, it's not completely optional. There are points involved, but if you missed a discussion board or if you didn't complete it on time, it wouldn't cost you attendance-wise. Notice also there's a video that essentially it's kind of like the notes that I give to my traditional students on this material, chapters 1 and 2, but it's in an online form. So it's about 40 minutes long. You may not want to watch it all in one sitting, but if you can during the course of the week, just like you would attend a lecture, make sure you watch that video. It'll help to put things in context. And we'll just go ahead and click on. I wanted to point out the lab activity. When you come around to the lab activity, notice it's actually a simulation. It's called the Rotating Sky Lab. I give you a link to the simulation, I give you a link to a student guide, and then I give you a link to a lab quiz. Notice that there are also several video tutorials which help you to understand what the simulation is trying to teach. Please note that a lot of these do say Module 2. When I first recorded these videos, I had this particular lab activity in Module 2. I've changed the order of the course, and I just have not redone the videos. But the information is still valid and good. You'll just notice that I make reference to Module 2 when it's actually in the current Module 1. Okay, all that being said, I strongly encourage you to do the student guide. It's not something you're going to turn in, but in order to understand the simulation, to get through all the bells and whistles and really understand the concept that the simulation is trying to teach, you really get it best by doing the student guide. Now, none of these videos actually go through the student guide blow by blow, but I'm actually going to try to do that for you here in Module 1. So if you've printed out the student guide, it's going to look like this. So there's your student guide, and you can read the instructions. I'm going to take you right to the first activity, in which we're using this simulator. It's called the Rotating Sky Explorer. And notice question 1 says, complete the following table involving horizon coordinate system. You should predict the answers and then use the simulator to check them. Remember that you can measure coordinates by dragging the active star to that location. So they want us to give the azimuth and altitude of the west point on the horizon for any latitude. So what does that mean? So that means, remove all stars. Again, you got this little dude. He's your observer. He can look in any direction. He can look north, he can look east, he can look south, he can look west. If we put a star on the west point of his horizon, it doesn't matter what latitude. I can change his latitude if I want to. You change the latitude just by dragging the dot. But it doesn't matter what latitude he's at. If I put a star, and you get a star by hitting Shift and clicking. I created a star on the west point of his horizon. Notice he's looking. He sees a star out in his western horizon. And the question is, okay, well, what is the altitude and azimuth of that star? Well, notice the information given to you. The altitude is 0 degrees because it's right on the horizon. The azimuth is 270 because it turns out the way we talk about which direction you're looking is essentially by the compass directions. North is 0 degrees azimuth. East is 90 degrees azimuth. South is 180 degrees azimuth. west is 270. And sure enough, that's where my star is. The star on the west point of my horizon is at 0 degrees altitude, meaning it's right on the horizon. It's not up in the sky, it's right on the horizon. And its azimuth is 270. That tells me, okay, I would have to look west in order to see that star. And that's what you fill in. So it doesn't matter what latitude, you can change any of your latitude. As long as you have a star on the west point of your horizon, it's going to be at azimuth 270, altitude 0. Now let's try another one. Let's do the zenith. Okay, what is zenith? Zenith is the point in the sky directly over your head. So if I take my star, my active star, and if I bring it up here, directly over my dude's head, pretty close. Notice, so he has to look overhead to see that star. It's directly over him. So what are the altitude and azimuth? Well, it turns out that the azimuth could really be anything. When you're looking straight over, you're not looking in any particular direction, you're looking directly up. What's the altitude there? Notice the altitude is right around 90. Notice that the star makes a 90-degree angle with the horizon. I can look in any direction toward the horizon. I would have to look 90 degrees up from that horizon in order to see my star. So in my student guide, I wind up with altitude 90 degrees. Okay, what does NCP mean? NCP means North Celestial Pole. So, and you can actually have that on if you put your labels on. And let's see, they want me to be at 30 degrees north. And now I do care about what my latitude is. So I can either move that dot, or I can actually type in 30 degrees. I want to be north. Now the question is, what's the azimuth and altitude of the North Celestial Pole if I'm viewing from 30 degrees north? So where's my North Celestial Pole? See that NCP right there? That blue little spike? That's my North Celestial Pole. So you can either remove your stars and create a new star at that location, and you do that by, again, clicking shift click, and notice I created a star right there at my North Celestial Pole. And the question is, okay, what's the altitude and azimuth of that star? Because I want to get the altitude and azimuth of the North Celestial Pole when viewed from 30 degrees north. Well, what's the altitude? Altitude is oops, sorry, I didn't enter my numbers right here. 30 degrees north is where my latitude. So again, my star is right there at the North Celestial Pole, and sure enough, my altitude is about 30 degrees. My azimuth is right around 360 or 0 degrees, so that makes sense. My guy is looking directly to the north. He's looking about 30 degrees above the horizon. So altitude 30, azimuth 0 degrees. That's what goes into your blanks here. All right, then let's do another one. I'm going to skip a couple of lines here. Let's do the one that says South Celestial Pole, Tropic of Capricorn. Okay, the Tropic of Capricorn, you can research this if you want, but it is about 23 degrees south is your latitude. So I can change this to be 23 south, and they want the azimuth and altitude of the South Celestial Pole. So again, when I look, notice there's a little SCP, that stands for South Celestial Pole. The question is, okay, what's the altitude and azimuth? I'm going to remove all the stars. I'm going to put a star right there at that spot. So I'm going to hit shift and click. So I've created a star that is right on the South Celestial Pole. And the question is, okay, what's the altitude and azimuth? Well, the information is given to me. The azimuth is 180. The altitude is about 23 degrees above the horizon. My guy has to look to the south now to see this South Celestial Pole, and he's got to look about 23 degrees above that southern horizon. And that's how you do this, so forth and so on. Okay, so that's how you complete that first table. The second part, question 2, gives you 3 different stars, and really wants you to, instead of just finding them in the sky, it wants you to find them in the sky and then change the time and see how they move. So, for example, 1B, it says draw in star A at the specified coordinates. Now they have a little diagram here, which is maybe kind of tough to understand, but this is essentially a diagram of the sky, where north again is 0 degrees, east is 90, south is 180, west is 270, etc. And that's why these little numbers are shown here. Now, my star is initially at azimuth 0 and altitude 20 at time equals 0. So when we first start caring about star A, it's at azimuth 0, altitude 20. So where would that be drawn in this picture? Notice azimuth 0 is due north. Altitude 20, that's, remember the altitude of the horizon. And that's what this outer band is, the horizon. That's why I love it, all the kind of trees and mountains and stuff. So that shows you your horizon, 0 degrees. Remember, overhead is 90 degrees. So notice that these little concentric circles, those give you the altitudes starting from the horizon, 0 degrees, and then climbing up 10, 20 degrees, 30 degrees, 40 degrees, 50 degrees, 60 degrees, 70 degrees, 80 degrees, 90 degrees. All right, so they want us to draw a star at 0 azimuth, which is due north, and then 20 degrees altitude. Well, remember, horizon is 0, here's 10, here's 20. So you could put a little star right there. And we can do that in the simulator by creating a star. Let's see. Oh, and we need to be at a mid-latitude of 40 degrees north. So if I'm going to do this on the simulator, I need to be 40 degrees north. And now I want to create a star at 0 degrees azimuth, that means due north, and then at 20 degrees altitude, that's pretty close, right? See, it's 359.9, 19.9. So I created the star that they've told me to create. Now, the question is, what's going to happen to that star in 6 hours? What will be the coordinates of that star? So here's what you do. You want to animate, let's animate for 6 hours. So I'm going to let this thing go now. So I've already pinpointed where it's at hour 0. And then I let it go for 6 hours. And notice what happened. Now that star has different values. It's now at azimuth 25.6 and altitude 37.1. And I can plot that then, if I want, on this graph. Remember, I started it here. Now I want the azimuth to be, whatever it was, 25.6. So I would go to 25.6. So remember, here's 0, here's 30. So 25.6 is somewhere over here. The altitude is 37.1, so now I have to go 10, 20, 30, 40, somewhere around here. I would plot my little star. And so forth and so on. And you let it go for another, I think it wants you to do it for another 6 hours or something like that. So where is it going to be 12 hours after we first started caring about it? So I can let it animate for another 6 hours and see where it winds up. So after another 6 hours, boom. Now look at where it's at. My dude can still see it, but instead of looking 20 degrees above the horizon, now 12 hours later, it's way up here. It is 60 degrees above the horizon. And again, its azimuth right now is essentially 0. So if I wanted to plot that, I'd plot another point at 0 azimuth, but then at 10, 20, 30, 40, 50, 60, I put a little dot right there. That's the motion of this star through the sky in the course of 12 hours. We started at time 0, we went to time 6 hours later, then we went to time 12 hours later, and so forth and so on. So that hopefully will get you started in the student guide. Again, if you have any questions, feel free to email or call. I may try to set up a video session. One thing I'll tell you in the student guide, ignore the very last part. This page 11, where it says sidereal time and hour angle optional. Yeah, you don't have to worry about that. More important to me is that you understand that, first of all, stars do move through the sky, and they move kind of in different ways depending on what your latitude is and how close the star is to the celestial poles. So keep all that stuff in mind as you're going through the student guide. Like I said, do the student guide first, then worry about doing the quiz. So actually you get to the lab quiz by clicking this link. It'll take you to the quiz. Like I said, more important is do the student guide, get familiar with all the functionality. If you want to kind of learn more about the functionality, like I said, I've got a bunch of different videos. Don't be put off at the fact that they mentioned Module 2. This is indeed your Module 1 lab activity. Again, these videos were just created quite a long time ago, and I've just not updated them. So anyway, that's at least hopefully what will help you in getting started with Module 1's lab activity, and like I said, continue to do the student guides every time you have a simulation throughout the rest of the semester.